Before I talk about the process of interpreting the results, it's probably also helpful to offer a brief overview of the processes that researchers use to determine those results. In other words, how do we use pages of interview transcripts and columns of numbers to make the statements we saw when we summarized the articles? Qualitative analysis involves various processes used to identify common themes. One commonly used technique is called grounded theory. The idea is that the researchers use the data they collect to develop a theory about a particular variable or a set of variables, or about the experience of a particular group. The process starts with a written transcript or other representation of the data. Then members of the research team review all of the data to identify the ideas that are repeated. When the team agrees on a set of ideas, then they organize them to identify broader themes. Then they interpret the themes. In other words, they explain what it might mean that the themes are what they are. Reports of qualitative studies often use quotations or examples of images to support the explanation of the themes. Quantitative analysis uses statistics. If the idea of statistics is familiar enough to make you a little nervous, I hope I can set your mind at ease. We won't be doing any analyses or even looking at any specific numbers. I hope, though, that the way I explain it here helps make it seem a little less intimidating, if it seems that way, and makes it easier to understand when you take statistics class. That said, we typically think about two types of statistical analysis in research: the descriptive statistics that describe the sample, and the inferential statistics that determine if the data from the sample allows us to draw conclusions about the population. At a practical level, descriptive statistics help us understand the characteristics of the sample. The technical way to think about that is that they help us determine how responses are distributed. Central tendency measures help us understand what's typical, but each measure of central tendency defines typical a little differently. Central tendency is also less meaningful without also knowing how much the scores range. Given that, quantitative researchers provide information about central tendency and about variability for each variable. I tend to think of inferential statistics as being like a combination of logic and math. Right now, we emphasize two types of analysis. Probability analysis determines the likelihood of something happening. We're never confident that something is impossible, that it's not ever likely to happen, and we're never 100% sure something is going to happen. That's pretty true of real life and of human nature, and that's part of the reason we don't say prove or disprove in social science research. Another way to think about it is that probability analysis helps us understand whether a finding means that there's a systematic relationship between variables. The alternative is that our findings are just due to chance, so they might not ever happen again, or at least not consistently. We call this statistical significance in research. If the probability analysis indicates that there is a systematic relationship, then we go on to the second type of analysis, effect size. That helps us determine whether the relationship is actually meaningful. As a quick side note, you might have noticed that I say right now we emphasize probability analysis and effect size. I didn't mean right now to mean in this class. There's a bit of a debate about whether we need to emphasize effect size more and also use other types of analysis. Most of what you'll see will emphasize probability though, so we're going to focus on that. I mentioned that statistical significance, remember that's the term we use for probability of a finding, is based on the likelihood of something happening. To make it even more complicated, we usually just refer to the p-value. We typically consider a finding to be meaningful if the likelihood of it happening due to chance is 5% or less. In statistical jargon, that's described as a p-value of 0.05 or less. When the p-value is 0.05 or less, we say that the findings are significant and interpret them as meaning we have identified a meaningful pattern in the variables. If we set aside the technical stuff, it's like when we flip a coin or roll a dice. We know there's a 50% chance of the coin landing on heads, or a 1 in 6 chance of the die landing on a 6. Inferential statistics just uses mathematics to determine the values for things that are more abstract. I tend to think of effect size as being like the scratch-off lottery ticket where you have to match a particular number or symbol to win something. So you scratch in a certain place to reveal your numbers or symbols, and then you scratch another place to see if any of the other numbers or symbols match yours. If you have the special symbol, that means you run 10 times the prize value. You could scratch all of the numbers and not match anything. That's like having a result that's not significant. You also could scratch and find a match. Then we get a little excited, right? It's like a statistically significant finding. So then we look to see what we want. Oh, it's a free ticket. That'd be like having a low effect size. It's something we might still get our money back or more, maybe not. If we had the special symbol and won 10 free tickets, that might be a little higher effect size. At least we won something that's worth more than the money we spent. But what we're really hoping for is the special symbol and a large cash prize. That's like having a high effect size. So it's a really simple overview of how researchers use the data they collected to answer the research question or test a hypothesis. As a consumer of research, this is the first step in determining what the study adds to our knowledge. As savvy skeptics, thinking about statistical significance and the effect size can remind us to question whether a claim is actually based on patterns of behavior and whether those patterns are actually meaningful. One unwarranted assumption we encounter is when the situation is presented as if it represents a pattern or as if it's more meaningful than it is.